This is Vivek Tripathi. Um, Today in this demo, I'm going to talk about three things. One is changes made in software architecture in this sprint, components developed by me in this sprint, as well as I'll demo a unit test of one of the components I developed. So first, software architecture. In this sprint, we have added two new components, Azure Function and Azure Logic App. These two components are serverless components, and it provide benefit of easy scaling up and um, separation of concern. Um, we are using these two components for publishing data to blockchain, as well as consuming and publishing smart contract events to Cosmos DB. Whenever a vote is saved, it calls Azure function, and that calls in turn calls transaction node. Whenever a smart contract event happens, that is decrypted here in Azure Logic App, and then it is saved into Cosmos DB. I would also like to talk about credit file service. It was a question in last sprint. We're using it to validate identity of the voter registering online. This is a well-established approach to ask questions based on credit file of a user and then establish the identity of that user. Next, I'm going to talk about components developed by me in this sprint. I worked on blockchain and provisioned a private consortium of blockchain, eVote USA. I also provisioned a member with uh, uh, transaction node as well as validation node. Both nodes are named same way, Chester PA. Um, Link is provided here and access is also granted. Next, I developed a smart contract using Remix IDE, using Solidity language, and it was unit tested using um, Remix ID as well as Visual Studio Code, and test results are available here, and sources available here. This is Remix ID, where very easy and helpful to use for a smart contract. It also provides a unit test option, so that's the option I have used here. So I have already set up ballot using the set ballot option, set ballot method. And when we transact, we have passed two candidate IDs. In this smart contract, to reduce the amount of data we are saving on blockchain, because that makes it sluggish. What we have done is that candidate ID is a combination of three digits of precinct ID, digits of seat ID, and then five digits of candidate ID. This way, any vote recorded for a particular candidate is stored just by these numbers, storing with the candidate unique ID. Um, to record a vote or voting to start voting, you need to first lock a ballot, and when a ballot is locked, it cannot be modified. So and I have already performed that action, so I'll just perform record vote. So when you perform record vote, let's see here, it shows the results here. It is showing that decoded input was this, and it was for this candidate UID, and it was successful. Let's check. We have created a property, get vote count. Since it is property, it uses no gas for execution. So we are going to run this and call this, and it will tell us how many votes have been casted for this candidate. So it shows here 3, and that's the end of unit test for Azure Function App. This function app works as a client between controller and blockchain. It provides methods like record vote, set ballot, get vote count, lock ballot, unlock ballot, and check ballot lock status. Um, um, Unit test results and the source code is available here. Unit test was performed using Visual Studio Code as well as Postman. Azure Logic app was also developed, and this app is basically decrypting any smart contract event published by blockchain, and then it stores data into Cosmos DB. Uh, since it is Azure Logic app, unit test was performed on the portal itself, and test runs are available there for view. Um, the next is I also worked on APIs for controller and implemented two of the APIs for face and speech. Test results are sources available here, and test results are here. End-to-end test runs for two user stories which I worked on is available here on Azure DevOps. So all these links are functional. Next, I will move to end-to-end demo of this functionality. We're going to record vote for a voter. First of all, this voter should not have voted before, so that is being checked here. This voter has not voted yet, so we can use this voter. Voters are identified by their mobile number and state ID. This voter is associated with precinct ID 100, and he is voting for a seat number this and candidate this. When it's executed, we'll see a response here, which came back as true. Now the next is the database needs to be updated that this voter has already voted. So let's check that again. Okay, so vote casted is updated here. Now the next step is that it should publish an event. We'll check if it has already published an event or not. Um, so this app runs this trigger runs every 3 minutes, so it won't be running before because it has already run. So it has skipped 216, the one which we got, but it will, when it runs next, it will process it. So what we're going to do is we will manually trigger it for now, and that should do. So 317 it ran, and let's look at the event here. This event um, here we'll see what is the input. So here is the document which is being pushed as a part of the event. So trigger time was this, and uh, candidate ID is this, and this is being the total votes as of now in blockchain is 20 for this candidate. So that's being stored in the database as a next step. So next we'll check database for this vote count container, and here for the same candidate it's a unique record, and that gets updated every time a vote is casted, and the vote count is now 20 here. You can see the votes are recorded here anonymously, so it would not be possible for any buddy to identify who voted for which candidate, because only vote count is increasing here. The actual votes are recorded in blockchain ledger, and this is just the count coming here for tracking purposes. And this is the end of the demo. All the links and documents shown in this demo are available on the next slide of this PPT. Thank you.